All right, so this is the Law of Sines, section 8.1, part 1. The goals of this section and also the next are to complete triangles. What that means is that you're going to want to find the three side lengths and the three interior angles of a given triangle. Another thing we're going to want to know from these two sections is when to use the law of sines versus when to use the law of cosines. All right, so for the remainder of this two sections, and actually for the rest of this chapter, let's agree to use capital letters to stand for angles and lowercase letters to stand for the side lengths. For example, this is my angle C. Opposite angle C, I have side length lowercase c. Some preliminaries. The Pythagorean theorem. The Pythagorean theorem is going to be used quite a bit throughout a lot of things. The thing to keep in mind about the Pythagorean theorem, though, is that it applies only to right triangles. And in these sections, in this chapter, we're going to be getting away from right triangle trigonometry. So we're going to start dealing with other angles besides right triangles. There might no longer be a 90-degree angle involved. All right, another fact about triangles that we're going to be needing is the fact that the sum of interior angles of a triangle is 180 degrees. So if you add up the angle A plus angle B plus angle C, that sum should be 180 degrees or pi radians, whatever situation you're dealing with. All right, another thing that we're going to need about triangles is called the triangle inequality. And what the triangle inequality says is that the sum of any two side lengths is bigger than or equal to the third side length. That might not be so obvious, but I mean, think about it for a little bit. The sum of side length A plus side length B should be bigger than or equal to side length C. If the sum of side A plus side length B was smaller than side C, that would not be a triangle. The lengths of the sides would be too small to close a triangle. It would not form a triangle. You would have just three lengths that do not form a triangle. So this is kind of going to be useful to determine whether or not a triangle can be formed. Yeah, so keep this triangle inequality in mind. Think about this question. What type of a triangle are you dealing with if the lengths of two sides, A and B, is exactly equal to the length C? What does that triangle look like? Another thing to maybe some more preliminaries, things that we're going to be using throughout these sections in this chapter is pretty much any trigonometry we've covered so far. So keep your trigonometry game strong because you're going to be needing it. All right, let's get into this business of completing triangles. Remember, to complete a triangle, what that means is that you want to find the three lengths of the sides and the three interior angles. Do not assume that you're dealing with a right triangle anymore. Most of the trigonometry we've done so far dealt with right triangles, but now acute triangles are probably going to be what we're playing with. Acute triangle just means that it's not a right triangle. All right, so how do you find all of the dimensions of a triangle if what you're given is, right now we're in case 1, so if what you're given is one side and two angles. This is perhaps, I think, maybe the easiest situation in this business of completing triangles. This is also known as side angle angle, angle side angle, angle angle side. You get the idea. You're given two angles and one side. Let's call that case 1. Now, how do you find all of the dimensions of a triangle if what you're given is one angle and two sides? Now, there's two ways that can happen. There's two ways in which that can happen. One of them is called SSA, and the other one is called SAS. They're a little bit different, and they require different treatment whenever you're trying to solve these triangles. So let's think about this SSA. So you were given two sides and just one angle. But the way this works right now is that you're given an angle opposite one of the sides given. This case is difficult. This requires quite a bit of treatment. We're going to cover it in the next video. Your book calls this the ambiguous case. So in part 2 of this section, we'll tackle this situation. So you're given two sides and an angle opposite one of the sides. So the picture looks something like this. You're given side length B, side length A, and the angle opposite A. You're given side length C, side length B, and the angle opposite B, or whatever. You get side C, the angle opposite C. Notice that I do not draw a complete triangle. There's this gap right here. And the reason why this gap is there is because it could be the case that the information given does not complete a triangle. So maybe the two sides that you were given and the angle does not actually complete a triangle. There's no triangle to be formed. So that's why we need to leave this little situation kind of open, because I mean, for all we know, it's impossible to create a triangle with the information given. All right, within this case, so you remember right now what we're given is two sides and an angle. SSA meant that the angle was opposite one of the sides. Now we have this other situation, SAS. This is a situation in which two sides are given, an angle is given, but the angle is between the sides that were given. Here the picture, well, looks a little bit different. You have side length A, side length B, and you were given the angle right between those two sides. For this situation, for this SAS, we're going to need the law of cosines, and that'll be in a couple of 2 videos down the line. Right now, for this in this 8.1, we're going to be tackling case 1, the easy case, and this SSA. Okay, so let's see if we can take care of case 1. So remember, case 1 was where you're given two angles and one side. In order to be able to solve these cases, we need a tool called the law of sines. So let's see if we can develop the law of sines by hand. Let's give a little motivation for the law of sines. All right, so look at this picture over here. I have a triangle A, B, C. Imagine that there's a way that I can make a vertical line, so I can cut angle B in such a way, and by the way, I'm not splitting that angle B in half. Who knows? I'm just cutting angle B in such a way that I create a vertical line that intersects this horizontal line AC in such a way that the intersection makes angles of 90 degrees. So these two lines are perpendicular. The angle, this vertical line H and this horizontal line AC, they're perpendicular. All right, well, if that's the case, then what I've generated is two right triangles. There's this left right triangle, which has this angle A. So think of this as a small little right triangle right around here. And then I have another right triangle, this one over here. This one's a little bit longer. All right, so let me look at the left right triangle. I'm looking at the angle A, and what I'm going to say is that sine of A is going to be opposite over hypotenuse. So I've written that up here. Sine of A is opposite over hypotenuse. Now, let me look at this other right triangle over here, and I'm looking at the angle C, and what I'm going to say is that sine of C is opposite over hypotenuse. Yeah, so I've written that right here. Sine of A is opposite over hypotenuse, sine of C is opposite over hypotenuse. Notice that both of these expressions involve H, so I'm going to solve both little equations for H, which is what I've done here. I solve for H. So that means I multiply both sides by C on the top equation. I multiply both sides by A in this second equation. And now I have that H has two expressions, C sine A and A sine C. Both are equal to H. So I'm going to set them equal to each other. That's what I've done right here. Okay, and from this little equation here, what I do is I divide both sides of this equation right here by the product AC. If you do that, you end up with this little equation right here, which says that sine of A over A equals sine of C over C. That is the law of sines. We could have drawn this picture a little bit differently, labeled it a little bit differently, and we would have been able to conclude that sine of A over A is equal to sine of B over B. We could have also concluded that sine of C over C equals sine of B over B, etc. That is our law of sines. So the law of sines says that these three ratios are equal. Sine of A over A is equal to sine of B over B, which is equal to sine of C over C. Alternatively, we could just think about the reciprocals of all of these fractions. A over sine of A should be equal to B over sine of B, which should be equal to C over sine of C. It doesn't matter which form you use. All right, let's think about this case 1 again. You are given two angles and a side, and you want to find the rest of the information about this triangle, the other three missing dimensions. All right, so first exercise here. Let's solve this triangle. Let's solve the triangle ABC if A is 110 degrees, C is 20 degrees, and the side length B is 25 centimeters. If I was you at this moment, I would pause this video. I would probably take, I don't know, 5-10 minutes the most to try to see if I can find angle B, side length A, and side length C. Those are the three things missing right now. So pause this video, take a second to try to do that on your own. All right, so I hope that you actually went ahead and solved it on your own, and now you're just seeing the solution here. So let me kind of work out the solution here so that we can maybe verify our answers. The first thing I'm gonna do is find the missing angle, because I know two angles. It's easy to find the third one. So, oops, sorry. I need to pick my pen. All right, good. First, let's find B. All right, so then I think in order to find B, all I have to say is that, well, B is going to be equal to 180 degrees minus the sum of the other two angles, 110 plus 20. So that's saying 180 degrees minus 130. I guess then that tells me that B is equal to 50 degrees. All right, so far so good. I found the missing angle. I'm gonna need that. All right, now I need to find either side length A or side length C. It doesn't matter. So let's think about what's next. Let's find A and C. I don't know, doesn't matter which one you start with. I'm gonna find side length A. So let's find A. All right. Now this is where I'm gonna use the law of sines. What I'm gonna say is the following. I'm going to do the following. I'm gonna say sine of A over A is equal to, now let me think about the information that I was given and what angles and what sides I was given. I mean, I already know that angle B is 50 degrees from this previous part. We just concluded that angle B was 50 degrees. I also know that the side length B is 25 centimeters. So I am going to use the dimensions B. So let's see. I'm going to say sine of A over A should be equal to sine of B over B. Well, let me just kind of fill in here the numbers, and what we have is that what's our angle A? Our angle A was 110 degrees, so I have that sine of 110 degrees over A is equal to sine of B. We said that that was 50 degrees. Sine of 50 over 25 centimeters. And right now the units, don't worry about units. Just remember right now, since we're trying to find side length A, at the very end, that should be in centimeters. But right now, units are kind of irrelevant. Just make sure you have your calculator in degree mode. All right, so let me solve for A. So how do I solve for A? In order to solve for A here, what I'm gonna do is I am going to multiply both sides by A. So it's going to look something like this. Sine of 110 degrees. Excuse my penmanship, I'm still getting used to this writing on my screen business. I hope to get better. And this is equal to sine of 50 over 25, and all of this times A. See, all I did there was multiply both sides by A. And now, what I'm going to do is I am going to divide by sine of 50. So I want to divide both sides by sine 50 degrees over 25. Well, dividing by a fraction is the same thing as multiplying by its reciprocal. So I am going to multiply both sides by the reciprocal of sine 50 degrees over 25. And if I do that, then I end up with this. And I'm going to put parentheses around things just to be careful. All right, so that's what it looks like to solve for A. Now I'm going to use my calculator to figure this out. I am going to make sure that my calculator is in degree mode. So let me make a little note here about such a thing. Make sure your calculator is in degree mode, and let's agree to round to the nearest tenth, just to make life easy. Okay, so right now, literally, I'm punching this into my calculator. I'm gonna make sure that my calculator is in degree mode. It is good. I am going to use a lot of parentheses for things. So sine of 110 degrees, I'm putting it in parentheses. Times, I'm opening up another parentheses, and I'm gonna say 25 divided by, and then the denominator, I'm gonna put it in parentheses. Sine of 50 degrees. Now you just gotta be careful to close all the parentheses that you opened. All right, let's see what that is. I get about 30.7 for side length A. So 30.7 centimeters. So 30.7 centimeters is approximately equal to my A. All right, I hope that you got that. Make sure that your calculator is in degree mode, and I just rounded to the nearest tenth. All right, so I already have, I'm just missing one last thing. I'm just missing side length, what is it? C. I just need to find side length C. And in order to do so, I'm going to kind of do something very similar. So we found A, let's just say here finally. Finally, let's find C. All right, so something very similar. I'm going to say sine of C over C is equal to sine of B over B. I guess at this point you could have also used sine of A over A. It doesn't matter, because whatever information you have, we should get the same thing. All right, so angle C, we were told, was 20 degrees. So this is going to say sine of 20 degrees over side length C should be equal to sine of B, we said, was 50 degrees, so sine of 50 over 25. All right, And in the same way that we solved for A earlier, I'm going to solve for C right now. So I'm going to solve for C. If I solve for C, you should just say sine of 20 degrees times the reciprocal of my fraction, so 25 over sine of 50, and that's equal to C. And now I guess I gotta punch this into my calculator and see what that is. So let me do that. If I do that, I end up concluding that, again, be careful with parentheses, make sure your calculator is in degree mode, and round to the nearest tenth. Side length C is about 11.2 centimeters. 11.2 centimeters. That's what I concluded. I hope that we concluded the same. And that's it. I've completed this triangle. I know all of its 6 dimensions now. I know all of its 3 angles and the 3 side lengths. All right, good. So it's your turn now. Solve this other triangle ABC. Right now what you were given is that angle A is 30 degrees, angle B is 45 degrees, and side length A is 12 inches. So I'm not going to work out this example. I'll just tell you what the answers are. Just so that you can figure out, you compare your answers. But definitely take the time to do the example here. Practice with this. All right, so what I concluded after working this example out is the following. That C is 105 degrees. Length B is 17 inches, or 16.9 inches, and length C is equal to 23.2 inches. I hope we agree with that. Good. So now go to part 2 of 8.1. That's where we'll tackle the case of you're given one angle and 2 sides, but the angle is opposite one of the sides that you were given. That situation is going to be difficult. That's going to require a bit of time. So, all right. See you in the next video.